Continuity in mathematics is a concept that describes how smooth a function is. That is, when the graph is drawn in x and y axis, the graph is smooth. No jump in the function. A function has continuity if it does not break or jump on its own. So, for a function to be continuous, you have to check the continuity property. A function is continuous at a point x equals to a if what? If these three conditions satisfied. That is, the function f of a is defined. The limit as x approaches the point a of the function exists. Number 3, as x approaches a of the function f of x is equals to the function f of a. What does this mean as defined? That is, we avoid over 0 if it is what? In quotient. If it is in square root, avoid square root of negative numbers. So the function at that point should be defined. The limit as x is getting close to that point a in the domain should exist, and the limit as the function approaches a should be equals to f of a. Example function that is continuous is given f of x equals to x squared. Is this function continuous? For this function to be continuous, you check this theory property. Is this function continuous at point x equals to 2? So this function will be continuous at x equals to 2 if what? These three properties satisfied. That is, what is f of 2? F of 2 is equals to 2 to the power of 2, which is 4. What is the limit as x is getting close to 2 of the function f of x? Is this the same thing as 2 to the power of 2, which is equals to 4? Because if you text the limit, if x is approaching what? 2 of this function, that is when 1.9999, if you check the limit, it's going to be 4. And again, f of 2 is equals to the limit as x approaches to the function f of x. The function f of x equals to x squared, a continuous function. Why? It's a continuous function because number 1, the continuity property satisfied as what? F of 2 is equals to 2 squared, which is equals to 4. The limit as x approaches 2 of the function f of x is equals to 4. And number 3, f of 2 is equals to 4 and is equals to the limit as x approaches 2 of the function. So the three continuity properties satisfied, the function is continuous. F of x equals to 1 over x. Is this function continuous? To check if this function is continuous, check where this function is not defined. Of course, it's obvious that for all x in a real number except 0, this function is always defined. At the point x equals to 0, f of x is what? Undefined. That is, it doesn't make sense to say 1 over 0. In this case, f of 0 is undefined. So the limit as x is getting close to 0 of this function f of x, the limit as x approaches 0 of the function is not the same thing as what? F of 0. So the function is not continuous at x equals to 0. And again, it's also not continuous in what? In the entire real number. To check continuity at this point, simply check the three conditions f of 2. What is f of 2? When x is exactly 2, this is the case. This is the function. The function is 3. The second checking is the limit as x is getting close to 2. The function is getting close to 2, not at 2. This is the function. This is the function. This is 1. So the three conditions says f of 2 must be equals to the limit as x is approaching the point. But f of 2 now is 3. And this is not equals to 1, which is equals to the limit as x is getting close to 2 of the function. So this third property of continuity failed. So f is not continuous at x equals to 2. So what is this function saying? If this is the y-axis and this is the what x-axis, for where here is 0, here is positive x-axis, here is positive y-axis, here is negative y-axis, and there is negative x-axis. So meaning if x keep on changing, when x is 2, the function is what? 3. When x keep on changing, when x is getting bigger, the function is always 3. The function is always 3. When x keep on changing, the function keep what? Constant. That is, it's not changing. It's 3, 3, 3, 3. If you are here, y is 3, x changes. If you are here, y is 3, x changing. So this is how the graph look like when you connect it together. So when x is below 2, the function is always 1. Below 2, very close to here, the function keep on be 1. Be 1. If x is below 2, the function is always 1. The function x keep changing and y is what? 1, 1, 1, 1, 1. When x is minus 4, y is 1. So this is how the function look like. You see, between 1, 2, and 3, there is a jump in the graph. That is, at point x equals to 2, there is from 1 to 3 in the graph.